Hello and welcome back to Faceless Security, where we explore the world of technology and cybersecurity.
You know, when we hear about big industrial cyber attacks, it's easy to picture some lone genius hacker taking everything down in one fell swoop. But that's not really how it works. The truth is, most successful attacks on operational technology, or OT, they don't happen because of one single catastrophic failure. Nope, they happen because of a cascade of failures. Okay, so let's get into it. Basically, an attack gets through because a whole bunch of different defenses fail, one right after the other. And that's exactly why the whole game has changed for modern OT security. We're not trying to build one single perfect, super thick wall anymore. That's just not realistic. Instead, the goal is to design a fortress, one with multiple smart layers of defense that can actually contain an attack and stop it dead in its tracks before it spreads to the really critical stuff. So in this explainer, we're going to walk through the 4 big architectural principles that are basically the blueprints for this modern digital fortress. We're going to talk about layering your defenses, this idea of zero trust, why you need to build security in from the very beginning, and finally, how to tackle the huge challenge of securing the supply chain. All right, let's kick things off with our first principle. It starts with a really simple and honestly a pretty pragmatic assumption. You have to assume the attackers will get in. It's just a matter of when. So if you can't guarantee they'll stay out forever, what's the next best thing? Well, the goal shifts. It becomes all about slowing them down, spotting them when they're inside, and stopping them before they can get their hands on the crown jewels. And this strategy has a name. It's called defense in depth. The absolute key idea here is that no single security control is ever enough. It's just not. You need multiple overlapping layers of protection so that if one layer fails, and let's be real, we have to assume it will, there's another one right behind it, ready to stop the attacker in their tracks. This is a great way to visualize it. What you're looking at is a network diagram from NIST. That's the National Institute of Standards and Technology. And it shows defense in depth in action. See how there are different zones? You've got the main company IT network, then this buffer zone called a DMZ, then the actual operations network, and finally the field level where all the physical stuff happens. Each of those little red firewall icons, that's a barrier, that's a wall. It makes an attacker's job so much harder and way, way noisier. And look, these layers aren't just about firewalls. Defense in depth is about integrating people, processes, and technology. It starts with the basics, right? Physical security. We're talking gates, badges, cameras. Then you get into network security. Go a layer deeper and you have endpoint security on the actual devices, things like your programmable logic controllers or PLCs. And then you have layers for identity and for monitoring. The whole point is to shield the most critical assets, your safety systems, your core processes, so that even if the main IT network gets hit, the plant itself stays safe and operational. Okay, that brings us to our second principle, which really builds on that layered idea. But this is a massive shift in mindset away from the old way of doing things. It's a concept called zero trust. For years and years, network security was all about this castle and moat idea. You know, you build a big wall, a perimeter, and if you were inside the walls, hey, you were trusted. But what happens when an attacker gets over the wall? Well, they'd have free rein to do whatever they wanted. Zero trust just completely tosses that model in the trash. The new mantra is super simple, but it's incredibly powerful. Never trust, always verify. So what does that actually mean in an OT environment? It means we check every single time someone or something tries to access a resource. I don't care if you're inside the network or outside, you get verified. We also give out what's called least privilege access. That just means you only get the absolute minimum permissions you need to do your job and not an ounce more. And maybe most importantly, we just assume the network is already compromised. We operate from that mindset and continuously monitor everything for threats. Now, this diagram might look a little complicated, but the core idea is actually pretty simple. Just think of that policy engine in the middle as a super, super strict bouncer at a club. Before any user or any device gets to access anything, they have to go to the bouncer first. And that bouncer, our policy engine, is going to check their ID. It's going to check the health of their device, the time of day, and a ton of other things against a really strict policy. Only if everything is absolutely perfect do they get access. And even then, it's just for that one specific request. A second later, they got to ask all over again. Okay, but let's be realistic. Applying this in an OT environment is tricky. You can't just go around breaking legacy systems that might be decades old. You can't install heavy software on sensitive controllers. And you definitely can't add any network delay that could mess up a critical process. So, in the real world, zero trust in OT focuses on the biggest risks first. Things like locking down remote access for all your vendors, using secure jump servers, and really doubling down on strong identity management and network segmentation.
All right, our third principle takes a step back. We're moving away from the live network for a second and looking at how these systems are actually created in the first place. The core idea here is that security can't be an afterthought. It has to be baked in, right? It needs to be part of the system's DNA from day one.
There's a classic saying in security that just nails this concept. Security should be built in, not bolted on. Because think about it. Trying to slap security onto a product after it's already finished, it's expensive, it's messy, and a lot of the time, it just doesn't work. It's kind of like trying to add a foundation to a house that's already built. Good luck with that. And that's where something called the Secure Development Lifecycle, or SDLC, comes into play. What this process model shows is that security isn't just one step you do at the very end. It's not just a single testing phase. It's a continuous loop that's woven into every single stage of a product's life, from the very first concept all the way through to deployment and ongoing maintenance. So what does that actually look like? Well, in the concept phase, you're already defining security goals. When you're gathering requirements, you do threat modeling to figure out how an attacker might try to break your system. In the design phase, you have experts review the architecture for any weak spots. During the actual coding, you use secure coding standards. And then, of course, you do hardcore penetration testing at the end. The bottom line is, finding and fixing a vulnerability way back in the design stage is massively cheaper and safer than trying to patch it after it's already been installed in 1,000 different plants.
And that leads us to our final principle, which honestly might be the most challenging one of all. You see, an organization can have the absolute best defenses on the planet, but at the end of the day, its security is only as strong as its weakest partner. We have to talk about securing the supply chain. I mean, just think about it for a second. Your own defenses might be locked down tight, but what about your vendors? The companies that make your controllers, the people who supply your operating systems, the integrators who have remote access into your network. Every single one of them is a potential doorway for an attacker to just waltz right past all your fancy walls.
And the threats here are really serious, and they come in all shapes and sizes. An attacker could hijack a routine software update, sneaking in malware that you then helpfully install yourself. They could put malicious firmware on a piece of hardware before it even leaves the factory. Or maybe they just steal the login credentials from one of your third-party maintenance guys to get remote access. The attack vectors are just huge. So what on earth can you do about it? Well, the guidance from NIST on this is all about being proactive, not reactive. That means you've got to conduct serious security assessments of your vendors before you sign on the dotted line. You have to enforce super strict policies for any remote access they get. You should be checking the digital signature and integrity of every single piece of software before it gets installed. And this is a big one. You need to write security requirements directly into your legal contracts and have a plan for what to do when, not if, one of your key suppliers gets breached. Here's the key takeaway on this one. Even your most trusted vendor, a partner you've worked with for 20 years, can become an accidental pathway for an attack. The mindset here really echoes zero trust. It's not about getting rid of trust altogether. It's about verifying it constantly. Okay, so let's do a quick recap of the 4 blueprints for building our modern OT fortress. First, defense in depth gives us multiple overlapping layers of protection. Second, zero trust forces us to verify every single access request, which gets rid of that dangerous old idea of implicit trust. Third, the secure development lifecycle makes sure we're building security in from the very start, not tacking it on at the end. And finally, supply chain security reminds us that our security perimeter has to include our partners too. When you put them all together, these principles create a truly resilient architecture. It's a design that's meant to prevent those huge catastrophic failures by surviving not just one mistake, but that whole cascade of them we talked about at the beginning. It completely changes security from being a single brittle wall into a deep, layered, and smart fortress. So the only question left for you is, now that you've got the blueprints, which wall are you going to reinforce first?
Thank you for watching. Be sure to like, comment, and subscribe for more great content from Faceless Security.